15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again, and thank you for joining us on the podcast we affectionately call Space Nuts. I've never figured out why, but we're nutty as fruitcakes here, so that's probably the reason. My name's Andrew Dunkley, your host, and with me as always, astronomer Fred Watson. Hello, Fred.
Hello, Andrew Dunkley, fellow space nut. Yeah, it's, I don't know whether there's much affection about it. It's just what we call it.
Yeah, I mean, the name was tossed up and we just went, oh, yeah, whatever. We'll call it. It's got to be called something. And that's what happened. Anyway, we got a lot to get through today, so we better get stuck into it. One thing that happened recently is we celebrated, or in some cases commemorated, Australia Day, which happens on the 26th of January, marking the arrival of the first fleet and ultimately the occupation of this country, for want of a better term. But every year we honour Australians who have achieved great things, and there have been a couple in the field of astronomy that were honoured this year. So we'll talk about them. One of them, a very good friend of yours, Fred.
Indeed, yeah, they're all friends of mine, actually. There are three.
Well, you know, it's
one especially.
That's the thing. Astronomy looks at the wide open world and universe, but it's actually a very small community globally, isn't it?
There's only 23 of us.
Yeah, that's right. Or maybe a couple more. We're also going to look at the new image of Ultima Thule. That data keeps coming back. That's the funny-looking ducky sort of potato rock out past Pluto. And we've had a question from Andrew in Newcastle, which we're going to tackle. Andrew's got a problem. A technical problem, and he's come to us for the answer. So we're going to solve your problems, Andrew. We are. And if we can't, I've got the name of a really good psychiatrist. Okay, let's begin, Fred. But can I just steal the limelight for one little moment?
Of course, absolutely.
I'm very, very happy to announce and tell you that last week I released my latest book. And
Yay!
As you know, I've written a few over the years. I wrote a sports psychology book just for the fun of it, just to see if I could do it. I wrote a book about my grandfather in World War I, which came out as an audio book, and then we put it on paper. And then after my trip to Europe last year to the battlefields, I rewrote part of it, so we released a second edition. But while all that was going on, I was toying away with a science fiction novel, and it is now out, and I'm very, very proud of it. My brother designed the cover, and it's called Parallax. And just to sort of give you the short version, it's about a bloke who is in his early 50s. He gets thrust back to his birth by a solar anomaly and has to start his life all over again. Interestingly enough, all the knowledge he's gained in his 50-plus years stayed with him. And in his new timeline, there's a strange company called Parallax, and they want everything he knows. So that's the basis of the story. There's a lot more goes on. There are twists, there are turns, there's a bit of a time travel paradox issue, there's multiple universe issue. A lot of the stuff that inspired the story came out of interviews you and I have done over the years and the podcast, Fred. And there's this strange character in it called Dr. Fred Wilson.
Wow, good grief.
Yes.
Fred Wilson.
Yes.
I know him personally.
And he's called on a few times to try and deal with some of the issues that are confronted by our hero. So it's out. It's available everywhere, right around the world, through bookstores and online and an e-book version. So I'd love for people to read it and tell me what they think, because I have no idea.
Well, I'll tell you, because I will download it and read it, Andrew. I look forward to doing that.
Well, it was a lot of fun, and it's my first shot at science fiction, and science fiction is my favourite genre. So I had to write one. I've got probably 10 more science fiction stories in my head and written down so that I don't forget them, and I'll be working on my next one real soon. But yeah, got to flog the hell out of this one first.
You have, and many congratulations.
Thank
Andrew.
you, Fred.
Great
Yeah,
treat.
well, as somebody who's written several books yourself, you know what the process is like, and it can be really frustrating, but also very rewarding. And yeah, look for the cover. You can't miss the cover. It is bright purple and blue and pink, and yeah, it stands out. So yeah, let me know what you think. Really, really would like your feedback. So to the important stuff now, Fred, and the Australia Day honours, and a couple of people you know, one in particular, have got themselves a gong, as we say in Australia.
That's right. Yeah, that's the usual term. So let me put them in some sort of random order, beginning with a colleague of mine, Elaine Sadler, who is professor of astrophysics in the School of Physics at the University of Sydney, and she also directs a centre called CASTRO, which is basically an astronomy consortium. CASTRO is a network of something like 100 scientists over 7 university nodes. It's rather a big institution. So Elaine has done a fantastic job. There's a kind of personal connection I have with Elaine. Of course, as you were saying a minute ago, there are only actually about 10,000 astronomers, professional astronomers throughout the world. That's roughly the membership of the International Astronomical Union. And Australia has something like 500 working astronomers. And that sounds like a big number, but we still tend to know each other, at least within our own demographic. And I hate to lump Elaine into my demographic because she's quite a bit younger than me. But we do share one thing in common, and that is that we were both sitting on the summit of Siding Spring Mountain in the Warrumbungle Range of northwestern New South Wales, where the biggest telescope in the country is. I had time on that telescope. The rain was pouring down steadily, and I was supposedly scheduled on the big telescope. Elaine was scheduled on one of the other telescopes on Siding Spring, and there were 2 or 3 other people there, and altogether we made a fantastic night of Scrabble playing because there wasn't anything else to do. But that was my very first visit to Australia, Andrew, and I'll probably embarrass Elaine by telling you that was 41 years ago this year. It was in 1978. So Elaine, it's been marvellous to see Elaine's career flourish. She's a great scientist. She is also a great manager and well-deserving of her Order of Australia. She has achieved the rank of an officer of the Order of Australia, which is sort of the 3 bands to the order, and hers is the middle one. Also in the middle is another very eminent astronomer, Ron Eakers. Ron is from South Australia, although he did spend quite a lot of time in the United States because he was director of the Very Large Array there, and actually was also the foundation director of the Australia Telescope National Facility, which is a radio astronomy facility here in Australia. So a very well-known, very eminent radio astronomer. Now kind of retired, although it doesn't seem to have made any difference. You see him at all the, all the colloquia and all the talks and things like that. Ron has the distinction, and maybe it's an embarrassing one. He was the president of the International Astronomical Union, and indeed chaired the meeting in 2006, if I remember rightly. It was on August the 26th, when Pluto was reclassified as a dwarf planet. So he had to oversee a very difficult meeting because astronomers were very divided on their opinions about that. And he managed, I think, to some extent to pull it together with the help actually of Jocelyn Bell-Burnell, who we spoke about recently. Jocelyn was also there. So yes, he had a difficult task on his hands that day. And maybe that's not what he'd like best to be remembered for, because it's still quite controversial.
Oh, yeah. I was watching a TV show the other day that had nothing to do with stars or astronomy, and just in the middle of the conversation, Pluto came up, and one of the characters said, "It's not even a planet anymore." I mean, it's getting into everything. It's
Indeed,
it's one of those ongoing issues, isn't it?
Yeah, so it's all Ron's fault. He too is an officer of the Order of Australia as of the announcement on Saturday. But the person I know best of this group is Professor David Malin, formerly our sort of astronomer astrophotographer at what was then the Anglo-Australian Observatory. He retired, I think, in 2001. But basically, like Ron, he never really disappeared. He kept going with his astronomical imaging. He is very famous for putting the color into astronomical imaging in the 1970s and 1980s. He was the photographic specialist for the then new Anglo-Australian telescope, the biggest telescope in Australia, the one we've just been talking about. He pioneered a number of techniques, photographic techniques, which have funny names like unsharp masking and contrast enhancement, things that are now done routinely in digital processing. But of course, he did it all photographically, and he pioneered a 3-color method of making true color images of deep space objects. And for the first time in those days, people could see these radiant colors in the processing that he did that allowed you to see things in space as you would see them if your eyes were thousands, if not millions of times more sensitive. He started his working life as an industrial chemist. He worked in the north of England for a company called Silva. He credits them as having nurtured his interest in science and in technology, because he didn't go to university. He always regarded that as one of the things that his life let him down. It wasn't because he wasn't up to it. He just did not have the opportunity. He grew up in Lancashire. He's got an accent a bit like mine, Andrew, although he claims it's different because we come from opposite sides of the Lancashire-Yorkshire border. And as David says, there's naught good came out of Yorkshire except the road to Lancashire. It's a very well-known saying among Lancastrians. So I'm absolutely thrilled that David has now been rewarded, or at least recognised, in Australian honours. He has had many honours and prizes from international sources, but now here in Australia, he is a member of the Order of Australia, and that is brilliant news. And I'm absolutely delighted about that.
Yeah, I've seen a lot of his work over the years, and it is stunning. And if you do a Google search, or any search for that matter on the internet, just put David Malin in and click on your images, you just get smashed in the face by these wondrous pictures that he's created, and they are stunning. Well worth looking at. And congratulations to David and all the Australia Day Award recipients. Well deserved. You're listening to Space Nuts. Andrew Dunkley here with Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
Okay, Fred, it's like visiting an old friend. We keep going back to the New Horizons probe and the data it's sending back, not only the stuff from Pluto, but on New Year's Day, one of the great achievements in, I suppose, astronomical investigation or exploration was the passing by of the object known as Ultima Thule. And the latest image is coming back, bearing in mind this data is going to keep coming back over the next 20 months or so. So there'll be more new images to see, I imagine.
That's right. In fact, there's apparently another one on its way. The reason why we're talking about this yet again, and we've certainly given it quite a lot of prominence in the last few weeks, Ultima Thule is revealing its secrets. We're seeing steadily higher resolution images, and the new one that has just been received, and of course it takes a matter of time because of the very low bandwidth of the signals coming back from the New Horizons spacecraft at 6.5 billion kilometres away.
That's because they're using the Australian NBN service.
No doubt that is the case, yes. It's now seen at a resolution which is quite fine, actually, considering what we're looking at, 135 metres per pixel. But that comes with a wide-angle camera, or from a wide-angle camera on board New Horizons. And we know that the same image that we're looking at, you and I are looking at, maybe our listeners are too, the same image is also in the memory banks of New Horizons, taken at a much higher resolution by something called the Long Range Reconnaissance Imager, otherwise known as LORRI, but that has not yet been down-fed to the Earth stations so we can see it. However, we are getting some very, very enticing information from this wide-angle view that we've got of Ultima Thule. It's about 33 kilometers from one end to the other. It's two blobs stuck together, one now called Ultima, the other Thule. If I remember rightly, the big one's Ultima. And you can already see evidence of cratering on this body. Some very peculiar looking features. It's got the smaller part of the object, which is like the head of the snowman, the smaller ball, seems to have a huge crater in its side. With
it looks like it's been hit hard by something big.
Exactly, that's right. And no doubt there are others all over, because that's how these things, how they come together, by things crashing into them. But it's also interesting, though, that we can just see the image, just in case some of your listeners are not actually seeing it, because we're not on television here, so that will be quite understandable. But when you have a look online, the image is basically the sunlit side of Ultima Thule, but there is just a hint of what's called the terminator. That's the division between the bright side and the dark side at the top of the image, where the sun is basically, the sunlight is just horizontal on the surface of Ultima Thule. And you can see a number of smaller craters or pits. It's not clear what they are. They could be the result of, outgassing activity within the object itself, where gases are coming out for some reason or another, or they could be small impact craters. My guess is, looking at them with my expert eye, my guess is that it's the latter, that they are probably smaller impact craters. But it is just a fantastic thing to see. This is basically a monochrome image that we're looking at, although there is color available on that camera. We know it's already that it's a sort of pinkish red color. Lots of bright streaks on it, which also suggests that there is activity of some kind, or has been, on the surface, because bright stuff on an object like this is usually the more recent stuff. Powder that's been deposited on the surface. Remember,
you can certainly see that at the join where they've come together.
Indeed, that's right. Yeah, and it's two big balls of ice, basically. So it is going to be lightish in colour. And as you said, the neck region, the snowman's neck, is much brighter. And the suggestion there is that is powdery stuff that's fallen into the crack between these two objects that when they came together, so that they actually. They don't join as such. They are just in contact.
So what keeps them together, Fred? And could they be torn apart? Gravity.
Yeah, it's a great look. That's a great question, which leads into something I was just about to say, because one of my colleagues in Canberra did a quick calculation when we saw the first images of what the pressure might be between them. Given the fact that we've got these two objects which both have not very much gravity, but enough to hold them together, and the pressure is high. It's in the region of tons per square inch, depends on how much contact area there is between them. He was assuming, he just took a wild guess as to what the contact area is between them. Of course, if it's all at one point, then it's a very high number. If they've kind of flattened out a bit, so that these two things have squashed together slightly, then the pressure holding them together is much less. It's
like surface tension, I suppose.
That's right, and maybe there may be effects of that kind that help to. It's basically gravity that's doing the job, but there could be interesting surface effects going on at the neck region of the snowman. Yeah. The great thing is we're going to see far more over the next few weeks. You and I will be hard pressed not to talk about it on Space Nuts, so I apologise in advance to you. Who might have heard enough about it already. You're going to get more.
Well, you just never know what the next image is going to reveal, and it might be something incredible that we've never seen before. So that's the reason to do these missions and to find as much as we can, download as much data as we can. And with the technology that's available, we can do some amazing things now. And as we mentioned last time we talked about this, they've got their eye on another object. So they're going to do a second flyby. So it'll be interesting to compare notes, really.
That's right. That's We await further news on that. They will. The NASA mission scientists, Alan Stern, the principal scientist, will be, I'm sure, musing over what kind of trajectory adjustment they can make to bring another Kuiper Belt object, these distant objects are called, into the range of New Horizons.
All right, we watch with interest, but yeah, it's fascinating to follow the journey of the New Horizons probe. You're listening to Space Nuts with Andrew Dunkley and Fred Watson.
3, 2, 1.
Space Nuts.
Finally, Fred, an audience question. This comes from a Novocastrian.
Oh, good. Like yourself.
Yes. Andrew from Newcastle in New South Wales. I grew up in Maitland, Andrew. So I was just up the road. Spent a lot of my youth in and around Newcastle. It's a lovely city too. Just a beautiful city. Really, just one of the jewels of the east coast of Australia, if I may say so. Andrew has a question, and thank you for sending it in, Andrew. I bought an ex-Army Silva Compass tritium glow-in-the-dark for my astronomical observatory, and sadly it doesn't work. Both the tritium has decayed too much, and apparently the Rio in the concrete pad is distorting the Earth's magnetic field and causing a major error in pointing to magnetic north. Sad, but I got to thinking. We have compasses in steel battleships, submarines, four-wheel drives, etc., and they all work. Why am I having a problem, and is it an astronomical anomaly? And he says, keep up the wise and convivial podcast.
I think actually this is where we might have plenty of conviviality, but we run out of wisdom at this point. I like old compasses too. In fact, I have a small collection of military astro compasses, which were used in bombers during the Second World War.
Wow.
They're perfect little analog computers, quite extraordinary things, just built like a little telescope, mounting with lots of scales and knobs on them. I fell in love with them when I was about 9, and I think I've got 3 still. It might be 4 even, I can't remember. But they were used for navigation, as I said, in aircraft in World War II. Of course, magnetic compasses are more common, and I've got 1 or 2 of those as well because they're very nice. The interesting thing about magnetic compasses is that they point to the magnetic north rather than to the true north. And as we were discussing, I think it was last week actually.
It was, yes.
Andrew, that's on the Wonder, is the magnetic North Pole. It's sort of hot footing across from northern Canada to Siberia. So that is an issue with magnetic compasses, and it's why we have to have this world magnetic model, the map of the world that shows where the magnetic north truly is, depending on where you are on the surface of the globe. It's also true, though, exactly as Andrew says, that magnetic compasses have been used on ships and indeed submarines and other vehicles, and they all work. And while that's kind of true to a level, it's still better to have a gyro compass, which actually you can set to be pointing true north, and as long as it runs, it'll keep pointing that way. But I think the problem that Andrew is alluding to, why do they work in steel battleships, for example? And that goes back to this really interesting issue of what's called degaussing a ship, and that's to get rid of the magnetic field.
Yes.
It's apparently is something, and certainly the term degaussing, because Gauss is the basically the unit of magnetic field that we use in physics, a unit of magnetism, the Gauss, named after Carl Friedrich Gauss, very well-known German mathematician in the 19th century. So but the process of degaussing, which is a term coined by actually a British naval officer during the Second World War, is a way of reducing the magnetic field of a ship to zero, or as near zero as you can get. You can never get it quite to zero. And that was important because at that time, the German mines were actually triggered by magnetism. They were called magnetic mines for exactly that reason, that they detected the magnetic field of an approaching ship, and that triggered the detonator, which exploded the mine. And so it was a very dangerous thing to have in the waters of particularly the North Atlantic and the North Sea. The British fleet suffered, I think, quite heavy losses until this degaussing process was introduced. So all kinds of ways were tried. I think they used coils and things of that sort to try and reduce the strength of the magnetic field. It's got quite an interesting history, which is fairly easy to find on the web. I think special equipment was used, but there was also basically a strategic method of randomizing the magnetism of the ship's hull by changing direction in the ship as often as you could. So, what happens, you see, the reason why the ship's hull gets magnetic is because it's sailing in a more or less a straight line, and it basically aligns in some degree with the Earth's magnetic field. And because it's doing that all the time, and there's vibration taking place because of the ship's engines, you get the ship's hull being magnetized. But if you randomize the direction in which you're traveling, then that tends to reduce the effect of the Earth's magnetism. Of course, also you could do that. If you were already degaussed, it was a good way of keeping it that way, because as soon as you degauss the ship and you go off in a particular direction, it's going to start getting magnetic again. So it's interesting stuff. We're now, of course, talking about naval history rather than why Andrew's magnetic compass doesn't work. But it could well be due to, as he suggests, the steel reinforcing rods in the concrete base of his observatory.
Yeah, well, maybe he should get a new base. Although I was just reading through his email, there was a second part there. He said, I tried delousing, but it didn't work. It killed all the insects. So I think he's on the wrong path there. But, no, seriously though, it is really quite a fascinating piece of science, and he may well have to just find something else to replace that concrete pad. I
suspect that, in fact, having a compass in your observatory building, which I think is what he's doing, his astronomical observatory, it's not really something that's essential, because your observatory really needs to be aligned with true north, not magnetic north. And most observatories, once you put them down and point them in the right direction, they stay put. So a compass will be just a nice, I think, an ornament more than anything else, which I applaud entirely. I love having things like that around myself.
Fantastic. Well, I hope we helped Andrew. It does sound like your concrete pad could be the issue, or the Rio inside it. I don't know whether you managed to get a new batch of tritium though.
That's a bit harder to get.
Yeah. But that's the stuff, like he says, glow in the dark. That's that light green stuff, is it?
Yeah, that's right. Tritium's actually a gas, but that's basically the luminous paint often has a high tritium content.
Okay. Thanks again, Andrew. Loved the question. We love all your questions, and we try to get to as many as we can. And we certainly love talking to you, Fred, and hearing from you. So thanks, as always, for being a part of Space Nuts.
It's a great pleasure, Andrew. I wish I knew what I was talking about.
Yeah, me too. And we'll catch up with you again next time.
Sounds great. Thanks a lot.
That's Fred Watson, an astronomer at large, half the team here on Space Nuts. And from me, Andrew Dunkley, thank you for listening. Thank you for buying my book, Parallax. And we will talk to you next time on Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor.
This has been another quality podcast production from Bytes.com.